Great, so we're going to continue on with our chapter 2.2 notes in the textbook for grade 7. So we're looking at equivalent ratios and fractions. So we've already started this problem. When you're given a ratio, for example, in this case, the male to female snowboarders was 3 to 1, I could put that in my left side of my equation or my proportion. So that means I know 3 boys for every 1 girl. I could have turned it around and put 1 girl in the numerator and then 3 boys in the denominator. It works the same way. What's important to note is that what happens on the other side of the proportion has to match what's on the left side. So if the left side is what I know, the right side is what I want to know. That means the number of girls that I'm not sure who are coming on the trip is on the top, and then the 24 boys stay in the denominator. Now, in both cases, though, I'll always look to see how I got from one side to the other side. So from 3 boys to 24 boys, I notice that it's correct because I have the same unit on both sides. And also, I can find out the scale factor. So from 3 to 24, I need to find a scale factor that will move me from one to the next. And that scale factor is multiplied by 8. So that means what I do to the denominator, I have to also do this to the numerator, which means I expect then 8 girls to be going on this trip, because this is 1 times 8, or not will, but are expected to, on the trip. Because we are basing it on a ratio, we can never really predict the exact answer, especially if it's a prediction. That means our total number of people will be 8 plus 24, so we expect 24 plus 8 is 32 total students. Let's just define a couple of things. What a scale factor is. So scale factor is the number that you multiply by to make an equivalent ratio. Whereas a proportion is the number sentence that includes the equal sign that shows equivalent ratios. So which means you do need both in order to be able to talk about something that's in proportion. If something is in proportion, you can determine what its scale factor is, and if you know the scale factor, you can create then a proportion. So if we continue looking down at some examples of equivalent fractions and their scale factors, so if we just take a look here, so if I give the example 18 to 9 is then equal to the proportion 2 to question mark, pause the video and see if you can solve this proportion. If you see that you see this proportion, the 18 goes with the 2, and we see that it is the first number of the ratio. The scale factor is divided by 9. Remember, division and multiplication are in the same family, so that means when we multiply, we could also divide as well. That means if we divide the first number by 9, we also have to divide the second number by 9, so that we can find the hidden or the unknown number is 1. Likewise, if we have fractions that are set up in ratio set up in fraction form, I can find out this particular proportion. 15 over 25 is equal to 3 over what? Now I can find my scale factor again. On the top, my scale factor is divide by 5, and then it's the same on the bottom, divide by 5. What I want you to do is pause the video and give me 3 more equivalent fractions or 3 more proportions that will continue the equivalent fractions for each for this example. So after you've come up with this, after you've tried it out, you can use the scale factor of times 2, for example, and so we get an equivalent fraction or equivalent ratio of 6 over 10. I can even multiply this by 10, and so I can get 60 over 100, and then I can divide by 2 again, and I end up with 30 over 50. There are many possible answers are actually an infinite number of answers. Now, in terms of solving these or in terms of finding the unknown, you always have to set up the fractions accordingly. So the first one, here's the problem. If the ratio is 4 to 7 boys to girls for mall shoppers, how many boys will there be, or do we expect it to be, if there are 35 girls? So again, we always set it up with what we know and what we want to know. And also we set up our ratio that we know. So we know that the ratio is 4 to 7. So that will go under our know. That means we will know 4 over 7. Or if we prefer the ratio format, we can do that as well. I'm going to stick with the fraction format since it's a little bit easier to see. Also, I'm going to put the units in so that it makes it clear in terms of what will be on the other side of this proportion. What we want to know, if boys were the numerator, they will stay in the numerator, and if girls were the denominator, they stay in the denominator. Also, we fill out what we might know, what we want to know, from the other information that's in the text. So we have how many boys will there be, so we don't know the number of boys if we expect it to be 35 girls. Given this information, we can use our scale factors. So given that we know both of the denominators and we only know one of the numerators, we can use the denominators to find a scale factor. So to get from 7 to 35, we need to multiply by 5. Likewise, on the top, or on the numerator, we have to do the same, and we multiply our numerator by 5 as well. That means we expect, or we predict 25, sorry, we predict 4 times 5 equals 20 boys to be at the mall. Now, there's another way to do this as well. If sometimes you get a fraction where finding the scale factor is a little bit tricky because you either end up with lots of numbers that are difficult to write, then you can use a cross multiplication. And the way cross multiplication works is this. I don't know my number of boys. We will put a letter to represent that. Let's say an N, a certain number of boys, which will be N. N is equal to, we look at the way it's set up, and we see that the word cross multiplication means you multiply across. That means that if I have 35 times 4 will be the same as N times 7. That's a little bit confusing, but what we can do is we can draw a little fish to solve or to help us with these numbers. So we know that N is on the other side, so we'll start on the other side of the fish. And every time we travel across, we multiply. Every time we pass through the division sign, we're going to divide. So 35 times 4, because we're going across in a diagonal way. But then I'm crossing through the division sign, so divided by 7 equals N. So if you have 35 times 4 divided by 7, and if I do that on my calculator, I will still get the answer of 20 boys, where N is 20. What I want you to do is, I'll just give you a second example. We'll try 15 over 25 equals 24 over M. And what I want you to do is set up the fish and try to find out what the value of M would be. So after you've tried it out, we'll draw the fish. We start at M, we go across and up and around, so it looks like a little fish. And M is equal to, we start at the other end, so we start with 24. We move across, so when we go across, we multiply by its cross, which is 25. And then we're passing through the division sign to move up across the 15. So that means we're going to divide by 15 to get the letter M. So 24 times 25, because we're going across, we're going up through 15, so we divide, and that brings us to M. And once we solve this, then we see that M equals 40. Just to finish off today's lesson, we have a couple of examples where it'll be related to the textbook examples. So, first of all, a little note, always check to make sure that the answer makes sense. Put the number back into the proportion and see if that proportion actually makes sense. Number 1, measure the length of this scale arrow. If the scale is 1 centimeter to 12,000 centimeters, what is the actual length of this line? So this arrow is probably a really, really big arrow in real life, but we've drawn a scale version of it on our paper. So again, we set up our what we know and what we want to know. And we set up our scale on one side. 1 centimeter equals 12,000 centimeters, or 1 centimeter over 12,000 centimeters. This 1 centimeter is the drawing, whereas the 12,000 centimeter one is the real version. So what we want to know on the other side is the actual length of this line in real life. Well, we don't know the real version, but we do know the drawing size. So if we take our ruler out and we measure this, it ends up being 6.7 centimeters. So let's just review that. Our scale that we know is 1 centimeter to 12,000 centimeters. On the right-hand side, I want to know, I want to know the real length, but given the drawing of 6.7 centimeters. I can use scale factors because it's easy to find the numerators are the information that we know. So 1 centimeter to 6.7, the scale factor is times 6.7. And I do the same with the denominator. I take 12,000 centimeters times 6.7, and it gives me the actual length of this line to be 80,400 centimeters. So let's take a look at the second example. Press pause. See if you're able to set up the proportion first for it, and then once you're able to set up the proportion, see if you can draw it out. So here's how to solve it. Make a scale drawing of Mount Everest below. The actual mountain has a height of 8,850 meters, and the scale must be 1 centimeter to 110,000 centimeters. Again, so what we know and what we want to know, and we'll put the drawing version on top, and we'll put the real version on the bottom. That means for 1 centimeter in the drawing, we know that that's going to be 110,000 centimeters in real life. Now, what we want to know, we know the real version of Mount Everest, which is 8,850 meters. We have a slight problem here because we don't know the drawing, how high we have to draw this mountain. Well, given what we have here, we can take a look and see if we can make a proportion or find an equivalent ratio between 110,000 centimeters to 8,850 meters. Now, because the units are not the same, what happens is it's very difficult to use scale factors in this case. But what we can use is cross multiplication. And since we know that centimeters over centimeters is in the know version, that means we predict then our unit for the want to knows will be meters because they'll match on both sides. Even though the centimeters doesn't match with the meters, we know that vertically the centimeters to meters makes centimeters to meters. So at least we know that those units will match in that direction. So that means that what we want to know, and we'll just call this h for height, the height of Mount Everest is equal to, and if we draw our little fish, we go to the other side, it's equal to 8,850 meters times 1 centimeter divided by 110,000 centimeters. And so after we solve all that, we see it's a little bit tricky, and I lost my screen a little bit. But after you solve for the height, you find out that your height is approximately 8 centimeters. So then all you have to do after you've, or it should be 0.0, you get actually an answer of 0.08 meters, which for drawing's sake, you'll convert that to centimeters and you get 8 centimeters. So then I draw a little 8 centimeter version of Mount Everest, 8 centimeters. And I know that according to the scale, 1 centimeter equals 110,000 centimeters, that I will get the appropriate height for the real version of Mount Everest. So we have a lot of problems in the textbook that you can work on. And if you have any questions, we'll go over that in class. It was a little tricky lesson today, looking at cross multiplication, looking at scale factors, and looking at proportions. But hopefully you understood it, and good luck with the homework.